Hi guys, and this is going to be the first topic of Chapter 6, Systems of Equations. We're going to talk about graphing systems of equations to find solutions. So a system of equations is when you have two or more equations using the same variables. The solution to the system is the point that satisfies all of the equations. This point will be an ordered pair. When graphing, we encounter three possibilities: one solution, infinite solutions, or no solution. So if we have intersecting lines, that means we have one solution. So if we look at this example, we have the graph of negative 2x plus 4 represented by this first line, and then 3x minus 1 represented by the second line. The solution is where they intersect, so that is at a point 1, 2. Our other case is if we have parallel lines. They never intersect, therefore they have no solution. We know that parallel lines have the same slope, so if we have two lines with the same slope, we actually don't even need to graph them because we know that they are parallel. Coinciding lines is the third case. They are the same line. They'll be written in different forms, so you can't really see that they're the same line until you actually graph them. But it's when one line has infinitely many solutions, so every single point is the same, aka it intersects at every single point because it's the exact same line. So what is the solution of the system graphed below? Well, that's where they intersect, so I need to find the point of intersection, which is at x equals 2, y equals negative 2. And I always write my answer as an ordered pair with parentheses and commas. Find the solution to the following system. So if we have our first equation, I'm going to do this one in purple, it's in standard form. So what we need to do is graph by intercepts, which is our xy table, plug in 0 for x and 0 for y. When we plug in 0 for x, we get y is equal to 4. When we plug in 0 for y, we get x is equal to 2. So let's go ahead and graph those points. So 0, 4, and 2, 0. I will connect those with a line. And again, make sure we have arrows at both ends because it is a line that goes on forever. So our next equation is also in standard form, so I will do my work for this one in red. If we make our xy table, 0 for x, 0 for y, because we're in standard form, when we plug in 0 for x, we get y is equal to negative 2. When we plug in 0 for y, we get x is positive 2. So let's go ahead and plot those points. And it just so happens that that line has an intersection point at 2, 0. Therefore, the answer is 2, 0. Now it says don't forget to check. That means we can check algebraically in both equations. So if our x is 2, I'm going to plug that into the first one, and our y is 0. Let's see if that equals 4. Yep, 2 times 2 is 4 plus 0. And then 2 minus 0 equals 2. That is also true, so we check that. Now we're going to try graphing. There's two different types of lines. So my first line is nice, it's in intercept form, so I can go ahead and just graph it starting at negative 3, and my slope is 2, so I'm going up 2 over 1 every single time. Connect with a line, arrows at both ends, and then now we have one in standard form, so I will use my xy table to find out what my points are. 0, 0. So if I plug in 0 for x, I get y is equal to 1. If I plug in 0 for y, I get x is negative 1/2. So that's kind of tricky, so maybe I can change my standard form to slope intercept form by adding 2x to both sides. So for this line, I get y is equal to 2x plus 1. Right, I have a graph at 1 and going up 2 over 1. This is an example where we have the same slope. These lines will never intersect because they are parallel with the same slope. And I forgot to write it, but that means if they are parallel, we say there is no solution. Right, the next slide just kind of steps out what you need to do to graph, which we've already shown you, so you can have that for your notes, but we're going to move on. Go ahead and do these U-tries for me. And that will conclude your notes for tonight. Do not do the warm-up at the bottom of this page. That is for next class.